The first topic in our graphing unit is the coordinate plane. Some vocabulary with the coordinate plane. The two number lines that intersect at right angles form a coordinate plane. The horizontal axis is the x-axis. The vertical axis is the y-axis. The axes intersect at the origin, which is the point 0, 0, and the coordinate plane is divided into 4 quadrants. An ordered pair of numbers identifies the location of a point, and these numbers are the coordinates of the point on the graph. So if you look at the graph on the right, we'll notice a few things. Notice we have our y-axis here, so that is the vertical number line. We also have the x-axis, which is our horizontal number line. These two lines intersect at the origin, so right there in the middle is our origin. Also, here's quadrant 1. So starting in the top right is quadrant 1, and then we name quadrants going counterclockwise. So we have quadrant 1, then quadrant 2, quadrant 3, quadrant 4. Also notice that the quadrants are labeled using Roman numerals. Point B, which is up here in quadrant 2, has the coordinates -2, 4. If you start at the origin to get to point B, we would go left 2 and up 4. The x-coordinate of -2 is also known as the abscissa, and the y-coordinate of 4 is also known as the ordinate. Let's look at some examples of naming points and naming coordinates. So in number 1, it says name the point with the given coordinate. And referring to the graph on the right, we're going to name which point has that coordinate. In A, we have the point 4, -2. So if you remember from our ordered pairs, it's always x, y. So I know my x value is 4, my y value is -2. So if I'm looking for the point with the x of 4 and y -2, I'll start at 0 and go right 4 spaces, 1, 2, 3, 4, and down 2, 1, 2, I get to point C. Then for B, we have 4, 3, so our x is 4, our y is 3. So again, starting at the origin, 0, 0, we go right 4, and up 3, we get to point D. Letter C, 2, -4, starting at the origin, go right 2 and down 4. We get to point E. And finally, in D, we have -2, 1. Going back to the origin, this time we'll go left 2 and up 1, and we get to point A. Now in number 2, we're going to refer to the same graph, but this time we're going to name the coordinates for each point. So if I want to name the coordinates for point B, and I locate that point B is in the center. So, and actually it's at the origin, which we wrote down earlier would be 0, 0. So that's the point where x is 0 and y is 0. Now point F, to get to F, we'll start at the origin, and I notice I have to go left 1, 2, 3, 4. So that tells me my x value is -4. And then I have to go down 1, 2, so my y coordinate is -2. So F has the coordinate -4, -2. Then for G, going back to the origin, to get to G we have to go left 1, 2, 3. So I have an x coordinate of -3. And I have to go up 1, 2, 3. I have a y coordinate of +3. Now we're going to look at some examples where we identify the quadrant where each point lies. If you need to, you can refer to the graph just above these examples, or you could go back to the first page and refer to the graph where the quadrants are marked. And I'll even sketch that off to the side here. So if we had our x and y axes, so here's x and here's y, and remember this is quadrant 1, 2, 3, and 4. Alright, so letter A, it says we want to identify where point -1, 5 is. So that's where x is negative and y is positive. That will put us in quadrant 2. Letter B, where the coordinate 3, -4 is. So x is positive, y is negative. That will put us in quadrant 4. And finally, the coordinate -1, -6. So both x and y are negative. We would be in quadrant 3. Okay, number 4 says, if the x-coordinate and the y-coordinate of an ordered pair are positive, the ordered pair is in quadrant. So if both are positive, we're going right and we're going up, we'd be in quadrant 1. And finally, number 5, the x-coordinate is 0, the y-coordinate is negative. Is the point in quadrant 3? Explain. So I'm going to go back up to where I sketched our axes and wrote down our quadrants. So if the x-coordinate is 0 and I start at the origin, I'm not moving left or right, but I'm going down. So let's say my point, it might be somewhere here. So am I in quadrant 3? Or am I in quadrant 4? Am I even in a quadrant? The answer to this question, it would be no. We're not in quadrant 3, and that's because the point is on the y-axis. The last thing we'll look at in this lesson will be graphing linear equations using tables. So it says in number 6 to model the function rule y equals -1/2 x plus 1 using a table and graph. So you're provided the table and the graph. A few things first. We are going to have some x values. We'll have our function in the middle, which will give us our y values. And finally then we will have our ordered pairs. So in the last column we'll write our x, comma, our y value. And then we can plot those coordinates. For these graphs, we're going to use the points -2, -1, 0, 1, and 2. And these are just x coordinates that I chose. Okay, you can choose any coordinates, but these are good ones to stick with graphing any type of linear equation. So what we're going to do is we'll take our function and I'm going to plug in my x value where x is. So we'll have -1/2 times -2 and then plus 1. And when we multiply that out, we get a +2. So that means my ordered pair is -2, 2. Alright, same idea in the next one. This time we're plugging -1 in for x. So we'll have -1/2 times -1 plus 1. And we will get a +1 and 1/2. You can write it 1 and 1/2, you can write it 1.5. Does not matter. So that means our second coordinate is -1, 1 and 1/2. Then we'll take 0. So -1/2 times 0 plus 1. Actually, I should be writing these guys in red. There we go. And we will get a +1. So then our next ordered pair 0, comma 1. Then same thing with the positive one, negative 1/2 times 1 plus 1. Did it again, there we go. We will get a positive 1/2. So here our ordered pairs 1, comma 1/2. And finally, negative 1/2 times 2 plus 1. We get 0. So our ordered pair here is 2, comma 0. So now that we have our sets of ordered pairs, we're going to plot them on our graph. So our first ordered pair will be negative 2, comma 2. So starting at the origin, I will go left 2 and up 2 and put a point. I will go back to the origin for my next ordered pair, and I will go left 1 and up 1.5 and put a point. Then going back to the origin, this time my point is 0, comma 1, so I will not move left or right, and I will just go up 1 and put a point. Then we have 1, comma 1/2, so right 1 and up 1/2. And finally 2, comma 0, so right 2, and we don't go up or down, we stay right there. So there are my points that will make up my line. Using your ruler, you want to connect your points and extend your line. Now I don't have a ruler, so I'm just going to draw it, but notice I extend my line even off the graph and I put arrows on both ends. Lines continue forever, so we want to put arrows to indicate that the line continues even past our graph. In our next example, we're going to model the function rule y equals 3x plus 4, again using a table and a graph. So I'm going to mark my x values, again using negative 2, negative 1, 0, 1, and 2. I'll put my function in the middle, 3x plus 4, and then I will put my coordinates x, comma, y. So just like the last example, we're going to plug in our x values for x and then find our y values. So I'll take 3 times negative 2 plus 4, and I get negative 2. So that means my ordered pair will be negative 2, comma, negative 2. Then the next one, I'll have 3 times negative 1 plus 4, and I get a positive 1. So my ordered pair is negative 1, comma, 1. Then we'll take 3 times 0 plus 4, and we get 4. So here ordered pair 0, comma, 4. We have 3 times 1 plus 4, we get 7. So ordered pair 1, comma, 7. And finally 3 times 2 plus 4, we get 10. So our last ordered pair will be 2, comma, 10. Okay, now just like the last example, we're going to plot these ordered pairs on our graph to make our line. So starting at the origin, first point negative 2, negative 2. So go left 2, down 2, put a point. Next ordered pair, negative 1, 1. So back at the origin, left 1, up 1, put a point. Again, back at the origin, next ordered pair 0, 4. So we won't move left or right, just go up 4. Now our next ordered pair, 1, 7. I can go right 1, but I can't go up 7. I run out of room, and that's okay. So you just need to plot the points that will fit on your graph. So in this case, we only have 3 points, and actually you really only need 2 points to form a line. So after you have your 3 points plotted, go ahead, take your ruler, connect your 3 points, remember to extend it off the graph, and draw arrows on both ends. Alright, here's our last example for graphing linear equations using tables. So it says model the function rule y equals negative x minus 2. And actually, if you want to hit pause, do this one on your own, and then you can check your answer to see if your graph is correct. But I'm going to go ahead and fill in my table, my x values, my function, and my ordered pair. Alright, so substituting again. Now, if you notice there's a negative sign in front of x, remember that negative sign also means take the opposite of your x value. So if x is negative, it's actually going to make it positive. So I'm going to plug in a positive 2 minus 2, and I get 0. So our first ordered pair is negative 2, comma, 0. Again, my next x value is negative, so that negative sign will change it to a positive 1, and then minus 2, we get negative 1. So our second ordered pair, negative 1, comma, negative 1. Now 0 can neither be negative nor positive, so we're just going to have 0 minus 2, we get negative 2. So our ordered pair is 0, negative 2. Now here, this positive 1 will become a negative 1. And minus 2 will get negative 3. So we have negative 1, comma, negative 3. The positive 2 will become negative, so we have negative 2 minus 2 to give us negative 4. So our last ordered pair is 2, comma, negative 4. And actually I just realized this 1 up here, let me change that. There should be a positive 1 there. Okay, so now that we have all our coordinates, we're going to go ahead and graph our line. So let's see, we have negative 2, 0, our first point. Starting at the origin, go left 2, and we're not going to move up or down. So our first coordinate is on the x-axis. Next one, negative 1, negative 1, so left 1 and down 1. Back at the origin, we have 0, comma, negative 2. So not moving left or right, just going down 2. Our next point is on the y-axis. Then we have 1, comma, negative 3, so move right 1, down 3. And finally 2, negative 4, right 2, down 4. Again, once you have your points plotted, go ahead, take your ruler and connect those points, extending past the graph, drawing your arrows, and your graph should look just like this. Okay, so good job on the graphing. Now you can go ahead and work on the coordinate plane and graphing linear equations using tables worksheet. There are 3 problems on the front and then 1 problem on the back containing 3 graphs that you need to fill the table in and graph the line on the graph provided.